proof of legal gambling. Okay? And oh, this is terrible. Let's say that 251 say yes. What is the probability that you get more than 52% say yes? You know, I'm going to change this question. Give me a poll of 501 teens. We're going to change the question. And you find, so a national poll says 50% say yes. You poll 501 teens. What's the probability that you get more than 52%? So you're comparing it. You're comparing your survey versus the national poll, which this is actually something that I'm going to want you guys to do with, this is the beginning of what we're going to call hypothesis testing, okay? So this is something that I'm going to want you guys to do for your project, okay? You've already done your poll. I've graded a few of them. Hopefully I will have that done this week. It takes a lot longer than I thought. And so basically what I want you to do is I want you to take some of this information that we're going to use. We're talking about probability. We can figure out the probability that your poll is the same or different than, say, the national poll. So I'm going to want you to take the information from this chapter and some of the future chapters, and we're going to do a hypothesis test where you're going to compare your simple random sample versus the national poll. Okay? All right. So let's do this. Okay? So the idea here is you can come up with a sampling distribution, and via the central limit theorem, the idea here is, okay, you're going to do a bunch of different polls. Okay? Now, if you do a bunch of different polls, okay, it should look kind of like a normal distribution. Okay? Now, hopefully your p-hat, okay, so you should use p-hat for your poll, is going to match the p of the population. Okay, so p-hat represents the sample, and p represents the population. Okay? So the idea here is, if we repeated this a bunch of times, now of course you guys are only going to be doing one poll, you're not going to repeat it a bunch of times, but if we were to take a bunch of different polls, this is going to repeat, and it's going to look something like this. And the poll is going to be centered at the population parameter. Now you don't know where your sample is. Your sample could be here, it could be up here, it could be anywhere. Okay, you don't know where that is. Okay? But the idea is, if we know, so if we compare the population with our sample, let's say our sample says 52% say yes. Is that significantly different than 50%? Okay? That's going to depend on how large your survey is. Okay? So one of the things we can do, you guys are familiar with the z-score, right? So conceptually, what's the z-score? Okay, you're going to need to know that for the test next week. Say it again. Okay, but I'm asking what's the formula? You're right, but what's the formula? Jordan? That's the data minus the mean over the standard deviation. Okay, so conceptually that's what it is. Now up to now, what's the formula I have given you?
Divided.
Z equals, what letters do you use?
Mu
X minus mu
over standard deviation.
sigma over I told you to stick something else on there. Square root of n, okay? Because I told you so I told you if they didn't give you an n,
And then 1.
then, what's that?
It was always 1.
It's gonna be 1. So the book, they don't give you this, but you're gonna use it today, okay? Now I'm gonna give you a new z-score formula today. You're still gonna want this one. And my new z-score formula conceptually is the same as this. It's the data minus the mean over the standard deviation. But here's your new z-score formula that works for surveys such as your survey. Surveys that you did, okay? I'm gonna want you to do this like 5 times for each one of your surveys, okay? The M&M project, that's gonna be chapter 24, so that's not gonna be on this test or anything, but that's gonna be, so after we cover chapter 24, you'll be able to do that one. It's not gonna be a z-score, though. It's gonna be a different test, okay? But the z-score for an opinion poll such as this, okay, this is what I want you guys to know, is going to be p hat minus p over the square root of pq over n. Okay? Now, conceptually, this is exactly the same, but what I've done is I've converted it from quantitative data to categorical data.
What is the square root? What's the thing underneath it?
Square root of pq over n. I'm going to explain that in just a minute. Okay? Okay, so essentially this is your data minus your mean, your population mean, divided by your standard deviation over the square root of n. But this time I'm going to put everything under the square root. Okay? So conceptually these are the same. Notation-wise, this is a little bit different because this is what we refer to as a binomial distribution. So I can have you figure out your standard deviations instead of measuring it. Okay? So the idea here is we want to know the probability that you get more than 52% say yes, given that the nation only usually says 50%. Okay? We're going to see if this is a statistical tie or not. Okay? So z equals, what's p hat in this case?
501.
The data, what's our data? It's going to be 52%. So 0.52, I'm going to make that a decimal. Minus, what's my mean in this case? It's going to be 50%, so 0.5, divided by the square root of, what's p?
The 501.
The same one here you got, right? P is the same. So it's going to be 0.5. So we got to distinguish between p hat and p. That can be the hardest thing, okay? So as you're looking through this, does this 50%, does that represent the population or does that represent the sample? This represents the population. What does this 52% represent? The sample, okay? So it doesn't say, it's not clearly stated in the problem, is it? Okay? But the idea here is you need to understand from the context, that's population, that's sample. And then you can plug it in here. So Q, I haven't told you what Q equals 1 minus P. So 1 minus 0.5 is 0.5. Divided by N, what's your N? Okay, so in this case, I'm going to get 0.02 divided by the square root of whatever that is. Let's see what that equals on here on my calculator computer. All right, pull up my thing here. Okay, so z equals 0.52 minus 0.50 equals the square root of 0.5 times 0.5 divided by 501. Okay, so this is going to give me this divided by that. Underline that so it looks like a z-score. So this is my z-score. Okay? Now at this point, I'm going to ask you, what would Rick do?
Graph.
We draw a graph. What's going on with this? What's that value there?
The mean,
That's the mean, and the mean in this case is
0.
0.
0. It's a standard normal curve. What value did I get? I got what?
0.895.
0.895. Okay. Does that mean 89.5% of the people, or that's the probability? No. That means I'm 0.895 standard deviations away, right? Now, the question says, what's the probability that I get more than 52%? So essentially what I've done, if this was a standard normal, if this was a regular normal curve, what would the mean be? What do we think the population value is?
Is it 1?
50.
50%. We think 50% of teens support gambling, right? What value did we get in our survey? 52%, 0.52, okay? When I convert that from a regular normal, so this was P equals, this is P hat equals. If I convert that to a regular normal curve with this equation here, I'm at 0.89 standard deviations away, okay? It's asking me what is the probability that I get more than 52% that say yes. So is that the left side or is that the right side? The right side. So I want this side shaded. Right? Okay, how do I find the area of that?
1 minus
It's going to be a 1 minus,
0.895.
and I can do the norm S dist, or I can look it up on the table. How do you guys feel about the table? We can do it both ways. Okay, so we do it both ways? Okay, so the table in the back of your book sucks. The table I'm going to give you is right here. Okay? So what do I do in this case?
We're looking for,
I'm looking for 0.895,
Mhm.
right? 0.895, that almost rounds, well, 0.89. So, it's too low, right? But let's call that 0.90, right? Because it rounds up. So 0.90, so this is 0.9, and then O would be this first column, right? So 0.9, I got that value there, 0.8159, right? Is the answer 0.8915, or whatever I said? 0.8159. So I got the value of 0.8159. Is that the right answer?
no,
No. This area here is 0.8159. I need 1 minus that, right?
mhm,
So if I do that, equals 1 minus, well, that's funny that those numbers are the same. Equals 1 minus norm S dist on that number. That gives me a value of 0.1853. So this is 0.1853. Actually, I didn't do that with the table. 0.8153, that's 1 minus that. No, sorry, I'm saying that wrong. So with the computer, we get 0.1853. If I pulled it up off the table says, so this is the computer. Table gave me the value 0.8159. And I'm going to do 1 minus that. Okay, so those values are pretty close. Which one's more accurate? Computer's a little bit more accurate. Okay, but the table, that'll be pretty good. Can you do it both ways? Okay? All right. So, do you guys have any questions for me? So the idea here is we're going to start using a new formula here, but this is all related to probability. Now, let me just show you this really quickly. I can't remember. I think this is the one. Okay, so 538.com, this was the prediction for Donald Trump to win the election. According to 538, he only had a 28.6% chance to win. Guess what? He won, unfortunately for us. Okay, so remember, just because something's unlikely to happen doesn't mean it's not going to happen. Okay? He only had a 28% chance to win according to the polls, but the polls ended up being wrong. Hillary was supposed to win 71%. At any rate, I'm just going to show you guys this, but this deals more with confidence intervals. We'll talk about this more when we talk about confidence intervals. I don't think I want to talk about it today, but at any rate, so you can figure this out. They actually come up with a mathematical algorithm to figure that out. So, do you guys have any questions for me? Okay. Well, let's go upstairs. We'll take our quiz, and then we'll